This question appeared in UGC NET Economics 2020 paper. And this question is asking you to match the different types of functions with their examples. But let us just talk a little bit about a function and these different kind of functions as well before you just give the answer. So what is a function? Please write alongside. A function is a relation between set of inputs and a set of permissible outputs. And a set of permissible outputs with one property, that each input is related to exactly one output, right? With the property that each input is related to exactly one output, right? So for example, there are two sets. Right. And here I have three elements, 1, 2, 3. And here I have A, B, and C, right? So this is the set of inputs, and then you have the output out here, right? So what do you have? You go from 1 to, let's say, A, right? Then 2 goes to B, and 3 also goes to B. So there is no problem that each input is related to only one output. There's no problem. So these are the inputs. 1 is related to A, yes. 2 is related to B, yes. 3 is related to B, yes, right? So each input is related to only one output. This is not happening now, that 2 is related to both B and A. Ye to nahi ho raha. So this is a function. This is a function, but you can easily make it something which is not a function. So for example, you have 1, you have 2, you have 3, you have A, you have B, and you have C, right? So what you have is this. 1 is related to A, okay? Input 2 goes to A, and input 2 also becomes B. No, that's not allowed, right? Input 3 goes to C. Now this is not allowed. This is not allowed, right? So each input should be related to exactly one output. So this is not a function. This is not a function. So the relation F has a property that each element of set A is mapped with only one element of set B. That's it, right? So relation F or a function F has a property. It is a relation F in which each element of set A is mapped with only one element belonging to set B, right? And the other thing is that these set A and set B, they should be non-empty. Right? They should be non-empty. Call this as set A, this is set B. Set A, set B. So can we write a little formal definition than the above one? So there is a function. So how do you write this? You write it like this. There is a function which is going from A to B. So this is a function which is going from A to B, where A is a domain and B is a codomain, right? So A is a domain and B is a codomain. So for an element belonging to a unique element B belongs to capital B, right, is there. Yeah. Such that is AB, they belong to this function, right? Such that AB belongs to this function. Now let's talk about the different kinds of functions which are given to you in the question. The first one. Linear function. First one, linear function. So this is a function which is forming a straight line in a graph, right? So it's an algebraic equation in which I'm just writing the definition. So let me just write the definition. It's an algebraic equation in which each term is either a constant or a variable which is multiplied with a constant, right? So it is an algebraic equation. Is an algebraic equation in which each term is either a constant or a product of a constant. Or a product of a constant, right? Constant and first power of a single variable. So you might have a function like this, y is equal to mx plus b. So y is equal to b is also just a linear function, or you are multiplying this constant with the variable x, and this x has a single, it is the first power, just x to the power 1. This is a linear function, yes. Right. And for each input of x, there is only one input, one output of y. So it satisfies the definition of function also, that is for each input x, there is only one output y. There is only one output y. So looking at this, A seems to be related to 4, right? A seems to be related to 4. That's right. Second one is a quadratic function. Right? A quadratic function. So one, it is a polynomial function with one or more variables with the highest power of 2. So for example, y is equal to ax square plus bx plus c. So you have the variable x also, you have the variable x square also. So this x has a power of 1 also, power of 2 also. So at least one or more variables has the power of 2. So how do you define this? It is a polynomial function with one or more variables in which the highest power is 2. So for example, you have fx equals to ax square plus bx plus c. So a, b, c are real numbers. And a is not equal to 0, because the moment your a is equal to 0, then the variable with the power of 2 has gone. So it becomes a linear function then in that case, and not the quadratic function. So what's the standard form of the quadratic function? The standard form of the quadratic function is this. So you have fx equals to into x minus h ka whole square plus k, right? So you call this hk as the vertex of the parabola. Well, this is a vertex of the parabola. And if a is going to be greater than 0, then in that case, the function is going to open upwards, something like this, right? So it is going to open upwards. And if a is less than 0, then the function is going to open downwards like this, right? So it is like this. So you have the parabola here, quadratic function like this. So well. So quadratic function, you look at this, and of course this is b. This is b. So that's right. Then what about exponential function? So you have the exponential function. So what is the general form of the exponential function? That y is equal to a to the power x with a greater than 0, right? That's the general form of the exponential function. The general form of the exponential function is y is equal to a to the power x, right? Where a is greater than 0. But if a is equal to 1, then it is just a horizontal line at y equals to 1. At a equals to 1. So if it is y is equal to 1 to the power even anything, whatever, 2, 3, 4, 5, it is just y equals to 1. It is a horizontal line at y equals to 1, right? But apart from that, there are two cases. There are two cases out here. Well, the first case is when A lies between 0 to 1. A lies between 0 to 1, right? So you pick up any value. I mean, for example, half, right? Y is equal to half to the power x. So you get a function like this, right? You get a function like this. So it is, of course, this is your x-axis, this is your y-axis. So as x is increasing, you're seeing that fx is going towards 0. Your y is going towards 0. So one thing, as x increases, fx goes towards 0. And if x is decreasing, your fx is going towards infinity, right? So and it is a strictly decreasing function, no? It is a strictly decreasing function, as you guys could see. It is a monotonically decreasing function. Right. And the other thing is that it is a horizontal asymptote at x equals to, at y equals to 0, at the horizontal axis. So it is not touching the x-axis, but it has a horizontal asymptote there. So asymptote along the x-axis, one thing. Then, right, then what happens is you have a function like this, right? So again, when you have a greater than 0, that's another case. A greater than 0, right? So what happens here is that as x is increasing, fx is going to infinity. So it is completely opposite of that. So as x increases, fx goes towards infinity. As x decreases, fx goes towards 0, right? And it is a strictly increasing function. And this has a horizontal asymptote along the x-axis. One thing is that. Along x-axis. Fair enough. And the most important exponential function is what? y is equal to e to the power x. So I've just written a to the power x. So here, I mean, and the value of e is what, 2.718 approximately, 28 and so on, right? So that's an exponential function. So in our question, right? So this one. So this is related to C. Okay. What is a power function? What is a power function? So it is a function which can be represented in this form. Fx is equal to k into x to the power p, let's say, right? Where k and p are real numbers. And k is the coefficient, right? So you have 5 into x is also is a power function. 5x square is also a power function. 5x cube is also a power function, right? But 5 to the power x is not a power function. That's an exponential function, right? So you have the function like fx equals to 1. It's an identity function. So can this be written as a power function? Yes. This could be written as x to the power 0. Yes, that's a power function. So you have a function like what do you call x, right? So this is a constant function, right? So this guy is a constant function. So fx is equal to just 1, y is equal to 1. It's a constant function. So here you have this x to the power 1. I mean, I can write like this. So yes, this is also a power function. Can you write, is this a power function? No. You need, for a power function, you need a base as the variable and a constant as the power. Here you have base as a constant and power as the variable. So that is an exponential function, not the power function. So no, it has a constant base. Raised to a variable power. Right, raised to a variable power. So that is one thing. So means, so of course, whatever is left out is that's what your power function. So D is this, right? So I can write this A also here. So that's an answer. That's an answer, beta. So thank you, beta.